Hi, can you hear me and see my screen?
Yes.
Okay, great.
Yes.
So hi, I'm Chien Lee from the Antares group. So it's our pleasure to give this demo today. So in this demo, I'm going to talk about how to interface with Antares. And later down in other sessions, our colleague Patrick Elio and also Deep and Carlson, they are going to demo different things like extragalactic science and also multi-messenger astronomy. So you can find Antares at antares.norlab.edu. What we do, so when you go to lab, you'll see our Antares web portal. So there are several ways to interact with Antares. So you can go to our web portal and then you can use our Slack channel. We'll notify you alerts when they comes in and if it's your interest. You can also interact with our client API, which is based on Python. So I'm going to first show how to use the web portal. So when you go to our web portal, you can see there are several ways to search alert. So it will direct you to the alert query web page. So you can search then on the timing of alert, number of measurements. We also cross-matching with different catalogs. And then we have different tags that are based on our filters. You can also look into them. So once you find it interesting alert, you can click it, and then it will direct you to alert web page, just like this one. It will show you the full light curve, and then it will link you to external brokers or other service. You can look into the properties of the alerts and then also the cross-match catalog. So say if you know just one single alert that you are really interested in, and then you happen to know the name of that alert, the easy way to do it is to go to antares.edu/loci/lookup. And then if you just happen to know the CTF name, like CTF 19A PR EIS, which happens to be the famous Taylor events, you can just type in the name, and then it will direct you to the web page here. So that's one simple way to look into the alerts. And then we also provide a watch list object. So if you have your own interest object, you can upload them to our own database using this form. And then we'll notify you when there's ever alerts hitting around this watch list, and then we'll send you Slack notifications right away in real time. We're also linking to the time toolkit that Curtis and David just showed. So if a customized Antares query form, you can query it either by the CTF object ID. If a simple query form, just mirror the query form from our web portal. And we also have an advanced query using the UXH query as a backend. There are other ways. If you want to interact with Antares in a programmatic way, we have an Antares document site in our FAQ. So if you just click FAQ, you'll see this. And then that provides a way to interact with Antares database in a programmatic way using Python, using our kind of API. So all this can also be done in our Astro Data Lab online service. So if you register for that, it's open for the all astronomy community, and then you can launch a Jupyter notebook there. And then we have a collection of notebooks that are coming by default. So if you look into that and then click the notebook latest, and go to the contributing one in the 10 domain, you'll see there's a bunch of Antares notebooks that are coming by default, and they are also uploaded to the Git repository of this workshop. So I just want to take this chance to show you one of the very nice feature of Antares, which is you can write your own filter, and then if you have that filter submitted, we'll run that in real time for you in the system, and then we'll notify you right away. So this is also a very nice way to interact with Antares database. So this is the notebook that shows you how to do that. So first you need to insert the dev kit. So it comes with the Antares package, but it's pre-installed for you if you go to the Data Lab online service. And then to write a filter, the most simple way to do that, the simplest one would be the hello world. So you can do like this. You can define a hello world filter and then put in the name here and then run your alerts. So in Antares, we associate all the alerts within 1 arcsecond on the same position of sky into a local subject, and that's the elements of Antares database, which called locus. So all alerts will be aggregated to the locus, and then we are built in on the locus basis. So you can get the locus, and then you can run your filter here like this one. So here it gives you an example of a real filter. For example, we have a high signal storage filter, and then you can define your name, the name of filter here, and then we also encourage you to use our Slack channel. So once you sign up for our Slack channel, you have a filter running, and then whenever there's error running a filter, we'll send you an error message. So you can check your filter and try to see what happens there and try to refine it. Also, when you define a filter, there may be some required properties like on the locus level or low level. And then you can also annotate those locus. You can just put it here, and then you annotate in the locus properties. And then you can define your text to output. And then once that is in our system, we'll also display that in our web portal. And then here in the run, it shows you how to define your filter, like threshold for signal-to-noise ratio, which kind of passband you're using. And then it's going through all these criteria. So here is more generic structure of the filter. So you can see all these blank sections. In principle, if you have your own criteria in like Python code, you can just fill in here. So you can just copy and paste all those into different sections here. And then once you're done editing a filter, you can do a test. So to test it, you can just run. So you can select a locus given its ID and then run it on a single locus given the locus ID. Or you can do, we encourage you to run more than one. So you can set a number like 100 or 1,000 just to better test your filter before you submit to us. All right, so that's about like 100 rounds. And then if you have like a vision for a unknown object, you really want to test it, you can even construct your own locus. So this is the way how you can build your own locus, like given its locus name, R index, and some properties like number of alerts, what's its magnitude looks like. And with that, you can define your own locus object, and then you can also run this on your filter just to test if there are some unknown or unseen new kind of transient that you vision will happen. Then you can even build a filter for that. So say if you are doing machine learning or different kind of stuff that you need to upload your own data to our thanks to add your filter, you can also do that by using this part. So once you are done, you can submit to Antares, go to our filter page on our web portal, and then you can submit there. So we do encourage you to keep some note there, like given your Slack channel username, then we can report bugs there. So that's one very nice feature to do to integrate with Antares. But we are more than that. So Antares is deeply embedded with NeuralLab service, which includes infrastructure to do follow-up with the suite of telescopes that we can access to, like a Scrum-based solar 4-meter and then the 8-meter Gemini telescope through US Open Access 10 under the umbrella of Ian. That's Rachel will talk tomorrow. So just want to quickly show you how we can go from end-to-end follow-up using Antares. So as Curtis mentioned, we are well connected to Time Toolkit, and then you can use Time Toolkit to trigger follow-up. So this is how we can use Time Toolkit and connecting Antares to Time and then to the follow-up telescopes, all using Jupyter Notebook. So for that, you need to install Antares and also the Time Toolkit in your local machine. And then you can import a locus here. And then once you've done that, then you can define object in your Time Toolkit just using this simple Jupyter Notebook like this way. And then you can see your object path here. Then you can fill out your observation form, just like this did, but in a more programmatic way in the Jupyter Notebook. And then you can send out observations using this form. So once it's been sent, you'll see that in your time toolkit, you can even go to your observation portal, like in the last conference, you'll see your object here. So we are connecting to more than time. We're also connecting to Sky Portal. So in Sky Portal, they'll give a talk like tomorrow, if I remember correctly. Then if you have its Sky Portal and you're using the REST API, you can simply do that. So you can import a locus object, and then you can define your API in this way, given a token. So once you have a locus, and then you can define the way you want to input into the Sky Portal using the API like this way, then you can construct a candidates. And then you can even populate with your just like this way by querying the Antares database. And then if you have a predefined or your own filters, you can even query your filter and then input all the locus there and then into the Sky Portal using this kind of method. So all these three notebook, the filter dev kit, Antares time ER, and Antares Sky Portal, they are uploaded to the Git repository of this workshop. So you can take a look. And that's all from my side for the interface.